All right, we're going to start applying the normal distribution now with some examples. Okay, so here's an example. What is the area to the left of z equals -1 in a standard normal distribution? The area corresponds to the probability around at least like the z-score is less than -1. So when you get these, I encourage you to draw a picture, sketch the bell curve, label this on the graph, and then think about what is it asking about the left, the right, or between some points. So we're going to sketch the curve. We're talking about z equals -1, so that's right here. And then the question asks us the area to the left. So we would sketch our line at -1 and shade the area to the left. So there's two important concepts here. One is area. We need to find a way to calculate the area that's shaded here. More importantly, though, what does it mean? This blue area, this area to the left of z is -1, is the probability that z is less than -1. And this becomes really important later. So let's talk about how you would do it. There are at least two ways. For our class, there's going to be two ways, and you can choose either one or the other. You're not strictly required to learn both of them. I'm just going to cover both of them. So the old school way is what's called a z-table. And a z-table is basically a big chart of areas to the left of z. There's a little screenshot here, but I'm going to pull up a full one over here. So here's a z-table. And what it is, you find your z-score with the column and the row, and then the value that's in a cell gives you the probability, or the area to the left, which is the probability that the z-score is less than whatever. So let's go back to the notes real quick. And let's do this one on my z-table. What is the area to the left? Sorry. Of z equals -1. I want to go back to, this picture. The z-table gives you area to the left. That's how it was designed. It turns out this is a calculus problem. Calculating the area under the curve is integration in like a Calc 2 class. The normal function, the PDF function, is very hard to integrate. In fact, it can't be done. So we use approximations. This is a little history on why the z-table is what it is. But let's actually do it. So what you're going to do is find the z-score that you want on a z-table, first with the column, and then that gives you your z-score in the tenths place, and then the row up at the top gives your hundredths digit, and that's as accurate as it can be. Okay, so we're going to find the -1, and then it's 1.00, so we want this one, and then in the column or up at top, we want the 0. So let me actually just show this on mine. So we're wanting -1, so we're going to scan down this, and sorry, it's this row. We want -1.00, so we go up to the top, and there's 0.00. So this is our area. It's our area to the left of -1.00. So the frustrating thing or challenging thing with the z-table is it's always the area left. That's what you got to remember. Work with it. In this case, that's what we wanted, so it was pretty easy. So the probability that a z-score is less than 1 is 0.1587. So this just walks through the same thing. So that's our conclusion. If we were randomly drawing a z-score out of a standard normal distribution, it's not too likely it'll be less than -1. So that's the z-table method. Let's talk about the calculator method. This one's actually pretty easy. What is the area to the left? Same question. Left of z is -1. What's the probability that a z-score is less than -1? The calculator has a command in the distribution menu called normal CDF, and CDF stands for cumulative density function. Cumulative means adding up, and it also goes left to right, just like a z-table. But actually, you tell it the left and right, but yeah, it does work left to right. This is accessed in the distribution menu. So I'm actually going to just pull up a calculator and do it live. So here's my little emulator, and we've typically been in the stat menu. Now we're going to jump over to this distribution menu because we're doing the normal distribution. So that's one way to remember. Normal distribution that's where we did the binomial stuff too. So second distribution, and there was our other stuff. But now we're doing the normal CDF. We'll never use the PDF version, so just it's always option 2, normal CDF. On a sort of newish calculator, you'll get a menu system, and the menu system wants 4 pieces of information: the lower bound, the upper bound, the mean, and the standard deviation. Remember, those are important. That determines everything. Where it is, how stretched out it is. But we're doing standard normal distribution, so that the mean is always 0 and standard deviation is always 1 for z-scores. We'll talk about raw data later. So the notes have you using negative 9,999. I prefer negative 1. This is scientific notation. Negative 1 times 10 to the 99 power. It's a much bigger number. The issue here is the probability of z is less than negative 1. Our lower bound, where's the picture? Okay. What's our lower bound here? This blue region that's shaded. Negative 1 is the upper bound. The lower bound is the left side as well. How far does this go to the left? Do we go negative 3? Even though the graph looks like it touches down here, it doesn't. The normal curve never actually touches down at 0. It goes to negative infinity and gets closer and closer. It's hard to imagine, but it never touches. So for this kind of problem, our lower bound is actually negative infinity. The calculator does not have a negative infinity button. So instead of negative infinity, we just need to use a negative number that's large enough that we'll get the right answer. So yeah. Let's go back to that one. So here, negative 9,999 represents negative infinity, and negative 1's our upper bound. So again, this is our left side of the shaded area. This is our right side of the shaded area. And our mean and standard deviation are 0, 1 because we're doing z-scores. Okay. And I hit enter. I did something wrong. I put a positive 1. So this is a good case where it helps to draw it out and make sure that your numbers you put in here match the numbers on your picture. But we wanted negative 1. So I found I did a different problem just then. Okay, so what the normal CDF gives you is the area between the 2 points you just put in. We put in negative infinity essentially and negative 1. Just for reference, I'm going to show you if we put in negative 3 as our lower bound, we don't get quite the right answer. Most of the area is between negative 3 and 3 z-scores, but there's a little bit past. So -3 wasn't good enough. For z-scores, honestly, -10 is a good enough. It's big enough to get you the answer. But when you start doing raw data, you'll just want to use a gigantic number for a -infinity or positive infinity. Okay, let's move on. What is the area? This is a new problem. Oh, okay, so to wrap this one up. Oh, one more thing on this one. If you have a fairly old calculator, you won't get this menu. You'll just get this screen and it'll be like a cursor. You just have to know, if that's your calculator, you're going to have to know that you want to put the lower number, the upper number, the mean, and the standard deviation. Okay, now let's do this new example. What is the area to the left of z equals 0.73? And this is something that we couldn't do with the empirical rule. In other words, what this is asking is, what's the probability of z-scores less than 0.73? So we would sketch our normal curve, put our line in the sand where we're working with at 0.73 right here. And then we want area left, so we're going to shade to the left. And now we would use either the z-table. I'll use my z-table to show you how it works again. So now our z-score is 0.73, and again, this is area left, and that's what we're doing right now. So we would find 0.7. It's on the other page. There's 0.7. And then there's our other here's our other digit. So 0.73 lines up with right here. So that is the area to the left of z is 0.73. It's also this probability that z is less than 0.73. That's the normal table, or z-table approach. Really wasn't that hard. The calculator approach, let's go to the calculator, go into distribution, and it's always CDF, and our lower bound is -infinity. Oh, I need to show you how to type that in. So yes, this would be good enough for this problem, but to be safer, I would encourage you to do this. -1, and then above the comma button is a big blue E. This is scientific notation. And this is saying -1 times 10 to the 99, which is -1 with 99 zeros after it. It's a massive number. Anyways, that's our left side, which is representing -infinity. And that's our right side. And our mean and standard deviation are 0 and 1, because it's z-scores. And that's my probability that z is less than 0.73. That's also the area left of 0.73 on the normal distribution. Okay, now we need to talk about one that's a little harder on the z-table, the area to the right. The z-table does not have a direct way to get the area to the right. It's always left. So we have to know two things to do this problem. One is the area from -infinity to positive infinity is 1. And 2, the area gives you the left. So to get to the area to the right, we're going to find the area to the left and subtract it from 1, basically. Let's walk through that. Still draw a picture, do your normal curve, find your z-score on it. It's going to be about right here. And then we want area to the right, so we're going to shade to the right. So our lower bound this time is 0.73, and our upper bound is positive infinity. But let's do the z-table. So we would find our 0.73 on the z-table, and that's the area left, or the probability of the left area. And we subtract that from 1. So that's our answer. This plus the answer is 1. The area left plus the area right equals 1. So yeah, we just find this number in there and subtract it from 1 to get our answer. It's a little bit more work, and this is when the calculator starts to shine. So as our lower bound, we would put our 0.73. As our upper bound, we would put positive infinity. And this is how I want to encourage you to do that. Always CDF. So our lower bound, 1, same thing, we're going to hit the big blue E. Till at 99, and then 0, 1 is good here. So the calculator is able to do right area much easier. Incidentally, these were just the opposite problems. So if I take the one I just got, this should reinforce the sum is 1. If I put all those digits in, I'd get 1. Okay, let's move on. This is the last kind, and this is a area between 2 points. And this is when the calculator is really going to shine. So what's the area between -1 and 0.73 in a standard normal distribution? So the standard normal is talking about z-scores, so we could write a probability statement like this, that z is between 1 and -1 and positive 0.73. And we could put these on a curve, so that's our lower bound, that's our upper bound, and we want the area between, so we shade the area between. The z-table approach is going to be a little bit of work. We'd find the area to the left of the right side and find the area to the left of the left side and subtract. So this picture shows a good summary of how you would do it. Find this blue area, find this blue area, and subtract it, because we don't want this white, or this white area down here, we didn't want it. So we would look at the z-table, get this one, look at the z-table, get this one, and then subtract it, and that's our answer. With the calculator, you just put in this as your lower bound, this is your upper bound, and you're done. So there's example. All right, we got one more short one coming up.